is working.
Wait.
All right. So here we go. Topic. We're talking about quadratic inequalities. Okay, there we go. 2, 5, 18. Nope, there you go. How's that? So, yeah, this is shading thing, exactly. So, quadratic inequalities. So, when we talk about quadratics, for us, quadratics are like parabolas or some x squared equation, right? Inequalities is the Pac-Man, the greater than, less than, greater than, equal to. So, when you look at inequalities, it's saying, it's really important you guys get this. It's not saying x equals. So it says x equals what? Blah, you get one answer. X equals 10. That's one answer. If it says x is, listen, if it says x is greater than 10, that's a lot of answers. I mean, it could be 11, 12, 13, right? And all the decimals in between, right? So we cannot list all of the answers. We can't. So what we have to do is either put it on a number line and show all the answers and shade it, right, Claire? Or we can put it in set notation or interval notation. I'm going to teach you interval notation today because interval notation is easier than set notation. So, example 1. We could try and plug in numbers here. And I want to do it the long, ugly way first, and then I'm going to show you the easy way because I want you to understand why it works. So, for instance, if I plugged in 0, if x were 0, right? Think about 0. I'd have 0, 0. I'd have 8. Is less than or equal to 3. So 0 would not work. You guys agree? So, but what about maybe try, I don't know, I'm going to try 10. What about 10? Well, let me see if I plugged in 10.
You can't see the calculator.
No, Katie, thank you. Oh, you can't see anything, can you?
Well,
Well,
so it's on the calculator.
you see now?
Yeah.
There you go. So if I go, say, 10 squared minus 6 times 10 plus 3, that still doesn't work, right?
Wait, it should be plus 8.
It doesn't matter. It's not something.
Yeah, it won't matter. So what about 5? Shh. What about 4 maybe? 4 squared minus 6 times 4 plus 8. That'll work. So what? I tried 3 answers. 0 did not work because it would make 8. If I plugged in 0, it would make 8 less than 3. I plugged in 10, did not work because I plugged in 10, I got 48, and that's not less than 3. But then I tried 4, and 4 worked because 4 gave me an answer of 0, and 0 is less than 3. So the problem is there's going to be a bunch of answers. We need to find the answers. Guess and check is not the way to do it, right? So what are we going to do? What we always do, we're going to eventually factor. We're going to do what we always do, okay? So we bring over the 3, because guess and check is going to be a pain, right? So let's just do some math. Let's bring over the 3, x squared minus 6x plus 5 is less than or equal to 0, right? And then I'm going to factor, right? I'm going to have an x minus 5 and x minus 1 is less than or equal to 0, right? Now what I'm going to do is solve, and I'm going to have x minus 5 is less than or equal to 0, and x minus 1 is less than or equal to 0, okay? So I'm going to do something right now. I'm going to change these to equal signs because what I'm looking for are what we call the border points. These are the points that make it equal 0. These are my border points. These are the points that make it equal 0, not necessarily less than 0, okay? So one border point is x equals 5, and the other border point is x equals 1. So these are my, what I call my border points. So let's put it on a number line, okay? So it's not x, y, it's just a number line because there's no y variable. There's no y variable, so it's just a number line. I want the values of x, so I'm going to go ahead and go to my number line, okay? And I'm going to have 1 and 5. Because it's has a little equal sign right here, right? It can equal 0, so I'm going to put a solid dot because of the equal sign here. Solid dot because it can equal this, and a solid dot on 5. There you go, solid dot. Solid dot because of the equal sign here. If there was no equal, then we wouldn't have a solid dot. We have an open circle, okay? We'd have an open circle because we say that it cannot equal that, okay? Now, all of my answers are in one of three regions, okay? All of the answers. Either here, we'll call this region 1, or they're in region 2, or they could be in region 3, okay? So how do we know? Well, we already tested a couple of points, actually. We already tested a point because we tested points on our calculator. We know that when we put in 10, it didn't work, right? Remember we plugged in 10? So I plugged in 10, and I did, so when x equals 10, I got an answer of 48. I got y equals 48. So I was saying 48 is bigger than 3. No. Oh, sorry, Katie, thank you. So we plugged in 10 on my calculator, right? And 10 didn't work, right? 10 didn't work at all because it'd be 48 is bigger than 3. Nope. So we don't shade anything in this region. Nothing, because that's 10 is in this region, okay? We tried 0. 0 didn't work either, right? If I plugged in 0, 0 didn't work either, okay? Because I got 8. I got 8 is less than or equal to 3, so I didn't shade anything. But when we tried 0, 0 worked, right? So that means everything within this region worked, okay? So if you were to pick any value in this region, plug it in for x, you would get an answer less than or equal to 3. If you picked any number in here, we picked 4, right? If you picked any number in here and plugged it in for x, it would give us an answer less than or equal to 3, okay? Now, that's the number line answer. Now, there's two other ways to write this. One is in set notation.
Is that what this is, or is this new?
Set notation is going to be like this. It's going to be 1 is less than or equal to x, which is less than or equal to 5. Okay, that's set notation. Okay, let's see if that makes sense. A lot of kids have a hard time with this. But if we read x first and read it backwards, read x first. What's it say? X is what? Read it backwards.
X is greater than 1.
Sure enough, that is greater, right? And then if we read x here, what's it say?
X is less than 5.
Okay, there you go. Okay, so here's a hint. Listen carefully because I'm going to give you a hint. These signs will be the same as these signs. The original question will have the exact same signs in set notation. Okay. Now there's a thing called interval notation, which you guys have never seen because I skipped chapter 1, right? I like interval notation the best. Interval notation has brackets and parentheses. If you use a bracket, it means it includes it. 1, 5. If you use a bracket, it includes it. Okay, that is interval notation. It says it's the interval between 1 and 5 inclusive. It says the answers are within the interval between 1 and 5 inclusive. It says the answer is within the interval of 1 to 5 inclusive. Okay, that's what interval notation does. I like interval notation better than that. It's easier. Okay, now let's check out question number 2. But I'll wait for you. Okay. And we'll learn interval notation because it's really not that hard to learn. Amber, pull it that way. Huh? Out right there? Up? Okay. How's that? Okay. Yeah. Okay, what do you see about example 2? It's the same question, isn't it? I did that on purpose, by the way. It's the same question. What's the only difference? It's switched, isn't it? Right? So we already know our border points on this one if we factor. We already know our border. Are going to be at x equals 5 and x equals 1, right?
We can't see it.
Okay. So we already know our border points, right? So we already did problem 1. Problem 2 is the same, right? Same border points. So if we were to do the exact same work, right? Bring over the 3. The only difference is you guys know it's going to be the opposite, right? So if I do my number line, right, and I've got my 1 and my 5, I'm going to have a solid dot, right?
We can't see it.
Okay, so I zoomed it way in. Okay, now we plugged in some numbers. When we plugged in 10, it was bigger than 3, right? So this region would be shaded, right? And when I plugged in 0, it was bigger than 3, right? I mean, when I plugged in my calculator, right? When I plugged in 10, I got 43. When I plug in 0, I know I get 8. So That's true. It would be bigger than 3, okay? So it's just shading the opposite direction, isn't it? So, in set notation, okay, I'll say it again. See this sign right here? I'm going to use the same sign. I'm going to say 1 is greater than or equal to x, which is greater than or equal to 5. Okay, write that down and we're going to look at it, okay? And if we read it backwards, okay, write it down. If we read it backwards, read x first. Read it backwards. X is what?
X is
Less than or equal to.
That's what I have, right? That's what I have, right? And now read it here. What's it say?
X is greater than or equal.
That's what I have, right? Interval notation is a little bit trickier on this, okay? So in interval notation, if I were to follow this to the end of its interval, where is it going to get to? Negative infinity, right? You can never get to negative infinity, so we use a parentheses interval notation. We're going to go parentheses negative infinity because you can't get there. If I could get to negative infinity and put a dot, I would, but I can't get there. So it's a parentheses, which means don't include it because you can't get there, right? Comma, 1, bracket, because you can get to 1. And then you say, or, because you got to jump from one interval to the next, bracket 5, because we can get to 5, solid dot. And then if I follow this line forever, where am I going to go? Infinity, right? Can I get there? No. If you could get there, you could put a solid dot, but you can't. Okay, that's how interval notation works. How am I doing? Okay, now, let's take a look at example 3. So if I take a look at these two, before I go on, and let me slide, everybody got it? Slide it down. Slide it down. So what can you tell me if it's less than? And what can you tell me if it's greater than? What do you see the difference between less than and greater than? Can anybody tell me anything? This is really going to help you, okay? Less than, what kind of shading do we do? And greater than, what kind of shading? Right? Less than, what kind of shading do we do? What kind of shading? In between. And the greater than? So my guess is on example 3, we're going to be outside, right? Okay, let's check it out. So first I'll bring over the 6. I'll have an x squared minus a 4x minus a 5 is greater than 0, right? Factor, girls? Girls, factor? Yep. Yes, factor. So when I'm looking for border points, I'm going to set it equal to 0 because I'm looking for when it does equal. So border point set equal to 0. Minus 5 plus 1, right? X minus 5 equals 0. X plus 1 equals 0, right? Plus 5. One border point is 5. Minus 1. Another border point is negative 1. Okay, so, all right. Okay, go ahead and put my number line down. Negative 1 and 5. And for me, I do not need all of the points in between, okay? I don't need, you can put them in if you want to, you know, all the numbers in between. If you want to put the numbers in between, go ahead. I just need negative 1, 5, works for me because I know what numbers are in. We're smart enough, right, Bailey? We know what numbers are in, so don't do it, okay? Unless you want to. So now, if I go back to this sign right here, I'm going to use open dots because it's not going to include, my answer will not include negative 1, and my answer will not include 5 because of there's no equal sign, does not equal my values. Okay, now, which way do you think we're going to shade? Which way do you think we're going to shade? Right? So let's put it in, we can test it, right? We can test it. So if we test it, I'm going to test it real quick on my calculator. So if I were to plug in, say, say 7. Let me plug 7 in to my equation. Can you see it? So if I go 7 squared minus 4 times 7 plus 1, will that be greater than 6? Yes, so 7 works. Let me test negative 2, okay? So if I go negative 2 squared minus 4 times negative 2 plus 1. Will that be greater than 6? Yes. So it works, right? Okay. Thumbs up so far? Okay. Set notation. Set notation on this one. We're going to go -1, greater than x, greater than 5, okay? So remember I told you whatever sign's here in the question is going to be the same way down here. But if we read it backwards, it makes sense to me. X is less than -1, sure enough. And x is greater than 5, sure enough. Interval notation. I want to do that real quick. Interval notation. We're going to go
Same on the top.
-infinity, comma, -1, parentheses. Hey, congratulations! Aren't you going to state?
Oh, yeah.
In the trombone?
Yeah.
Nice.
Thank you.
Or 5, comma, infinity, okay? Parentheses on both because it does not include it, right? Okay, real quick. Open circle, parentheses. Close circle, bracket. Okay, now, how do you know? Great question. Super easy. Okay, ready, Ashley? See the little equal sign right here? The little equal sign?
Oh.
Close circle.
Okay, I get it.
Okay, ready? No equal sign, open circle. It's that easy, okay?
I love doing inequality.
Okay, you ready? Turn the page. All right, now, how about example 4? How about example 4? Okay. Okay. Oh, not for a while. Not to March. Okay. Number 4. Shh. Does not factor. Okay. Does not factor. Bummer. So if it does not factor, we've got two choices. We could either use the quadratic formula, or we could complete the square. I don't care. What do you want to do? Complete the square or quadratic formula? Okay, let's complete the square. Okay, bring over 7. X squared plus 2x is going to be less than or equal to -7, right?
Yes.
Okay, remember we're going to complete the square. Half of this is 1. 1 squared is 1, so +1, +1, right? So then we've got parentheses x plus 1 equals -6, right? Or we get an x plus 1 squared equals -6, right? Square root. Oops. Since we're on a number line, we can only graph real numbers. This is a trick question. So it's either no answers or all answers. Yeah. So we're not going to get any answers at all. So if I plugged in 0, let's just test it, okay? Okay. So if I plugged in 0, what do you get? Plug in 0, what do you get?
7.
Is 7 less than 0?
No.
So there's no answers. No answers. Okay? So we either say mathematically, we'll say the empty set, and that's the mathematical answer for that. No answers, empty set, okay?
Plus or negative, no answers.
Yeah, plus, yeah, exactly. Okay, now how about example 5?
So no answer?
This one's different, because no matter what number you put in, it'll always be bigger than 0. This one's all answers. Okay?
Wait. Oh, never mind.
X equals all real numbers. Okay, and I'm not going to do the story problem. I'm going to go ahead and stop the recording there.